Hello. So my name is Francis Wanja, and my question was find the points on the cone z squared equals x squared plus y squared that are closest to the point -5, 3, 0. So the first step is to recognize that the points -5, 3, 0 are our x, y, z, or rather x1, y1, z1 coordinates. So the formula for finding distance on a plane is the square root of x minus x1 squared plus y minus y1 squared plus z minus z1 squared. And our x1, y1, z1 points are the points that we are given, -5, 3, and 0. So the easiest way for me is just to square both sides. So I have the square of d, which is d squared equals to x minus x1 squared plus y minus y1 squared plus z minus z1 squared. Now if we find the xyz values that minimize d squared, this will be exactly the same values that will minimize d. And then we change over the d squared with the f to put it in a version that is much more familiar. So f equals to x minus x1 squared plus y minus y1 squared plus z minus z1 squared. And then we just substitute the values that we are given here, the -5, 3, and 0, into the x1, y1, and z1. So we say f equals to x plus 5, the negative there changes to positive, squared, plus y minus 3 squared, plus z minus 0 squared. And then we have our function equals to x squared plus 10x plus 25 plus y squared minus 6y plus 9 plus z squared. So we have expanded it, and that's what we have. Now remember, the z squared value is x squared plus y squared. So we substitute this z squared value with the x squared plus y squared. So our function value now is x squared plus 10x plus 25 plus y squared minus 6y plus 9 plus x squared plus y squared. And then we group the like terms together. So we have 2x squared plus 2y squared plus 10x minus 6y plus 34. Now at this point, the next thing that we need to do is find the critical points. And we do that by finding the partial derivative of this function with respect to x and y, and then we equate it to 0 so that we can find those critical points. So the partial derivative of this function with respect to x means that we are going to just evaluate everything with respect to x. So the y value is going to be a constant. So we get fx equals to 4x plus 10, which equals to 0. So we get the x value to be -5/2. And then the partial derivative with respect to y is 4y minus 6, which equals to 0. And we get y equals to 3/2. So at this point we have the point x equals to -5/2 and y equals to 3/2. So these are our critical points here. The next step from here is to perform the second partial derivative test to determine whether we have a maximum or a minimum value. And we use this formula here, which is d equals to fxx multiplied by f second derivative with respect to y minus the derivative with respect to x followed by the derivative with respect to y squared. And if our d value is greater than 0 and our second derivative with respect to x is greater than 0, then we have a relative minimum. if our d value is greater than 0 and our second derivative with respect to x is less than 0, we have a relative maximum. So our second derivative with respect to x, we come back here to the 4x plus 10. So the second derivative with respect to x is going to be 4. The second derivative with respect to y is going to be 0. Actually, the second derivative with respect to y is going to be 4. And then the derivative with respect to x followed by the derivative with respect to y is 0. So basically, we are doing the 4x and then trying to find the derivative with respect to y, but since there is no y value, we are getting the 0 there. So we just plug these numbers into the formula. We have d equals to 4 multiplied by 4 minus 0 squared, so we have 16. So our d value is 16. Our second derivative with respect to x is 4. So when we come to these constraints here, you see that when d is greater than 0 and the second derivative with respect to x is greater than 0, then we have a relative minimum, which means that our point negative 5 over 2 comma 3 over 2 is a relative minimum. After we find that, we come back here, and now the last thing that's remaining is for us to find the z values, and the z values are just going to be got by just substituting the x and the y values. So we got x was minus 5 over 2 and y was 3 over 2. So we come back to our original equation, which is z squared equals to x squared plus y squared, which equals to, so this one actually, you can interchange them, 25 over 4 plus 9 over 4, which gives us 34 over 4. So our z value is the square root of 34 over 4, which equals to plus or minus the square root of 34 divided by the square root of 4, which is 2. So the points on a cone that are closest to the minus 5, 3, and 0 are, we've already found the x and y value, and we've found the two z values. So it's minus 5 over 2, comma, 3 over 2, comma, negative the square root of 34 over 2, and negative 5 over 2, comma, 3 over 2, comma, the square root of 34 over 2. And those are the points that are closest to minus 5, 3, 0 on the cone. Thank you.